This is an introduction to proof by contradiction, which is another method to prove that a statement is true. So in any proof, our goal is to prove that a statement is true. So our goal is we're going to prove, or we're attempting to prove, that P is a true statement. Okay, so if P is true, then you know, so if P is true, then you know that its negation of P must be false. Okay, so that's going to be our approach. Proof by contradiction does not prove that P is true directly. It proves that P cannot be a false statement. Okay, though that sounds like a word salad, but what you want to do here is we're going to assume, we know if P is true, negation of P must be false. So what we're going to do is we're going to assume that the negation of P is true. Now, you know P is true. So this assumption cannot be right. If P is true, its negation cannot also be true. So this assumption is going to lead us astray. What it's going to do, it's going to lead us to a logical contradiction. And a contradiction is something that's contrary to a known fact. Like you might do a proof by contradiction and show that 0 equals 1. Well, that can't be true. You might show that a rational number equals an irrational number, or an odd number equals an even number. All of those things are contradictions of known facts. So if you find that contradiction, that says that your assumption that the negation of P is true, that says that the negation of P is true cannot be true, which says the negation of P must be false. Because the assumption led to a contradiction. So we can't have that assumption. That assumption must be wrong. And if the negation of P is false, that shows that P must be a true statement. So we're going to work through a couple examples and some short videos. The first statement I'd like to work on is this one right here. It's an easy one. 2 is an even number. That is my statement P. Well, we know that's true, but let's complete this in a proof by contradiction. What we're going to do is we're going to assume that the negation of P is true. Okay, the negation of P would be that 2 is odd. So we're going to assume negation of P must be true. Or in other words, we're going to assume that 2 is an odd number. All right, so if 2 is odd, okay, so we've assumed that's true, so let's assume 2 is odd. So if 2 is odd, then we know that 2 must equal 2k plus 1, where k is some integer. Okay, all right, so if 2 equals 2k plus 1, let's play with this. Let's bring the 2 over to the 2k to the other side, do a little algebra here. So we know that 2 minus 2k equals 1, which would say that 2 times 1 minus k equals 1. Oh, but remember that k is an integer, and we know that 1 is an integer. So we're going to say that implies that 2 times L equals 1, where L, which equals 1 minus k, is an integer, and that's by closure of addition, okay? It's actually closure of subtraction. Okay, so what do we have here? Well, on one side, we know that we have 2L, and 2L is an even number. On the other side, we have 1. Oh, 1 is an odd number. So what have we shown? We've shown that an even number equals an odd number. So what I want you to do when you do a proof like this is just note the contradiction. You'd say, this is a contradiction. Raise the red flag. Contradiction. There you go. That's an I. Right? Contradiction. This is a contradiction. An even number cannot equal an odd number. So, what do we say? We found a contradiction. Our assumption that the negation of P is true, that P is odd, has led to a contradiction. That says that the negation of P cannot be true. Okay, so if the negation of P cannot be true, that says the negation of P is false, which says that P is true. So once we found a contradiction of this assumption, we know that, okay, the assumption cannot be true, so the original statement, P must be true, so 2 must be an even number. And that is our proof.